Semantic analysis of issues on Google Play and Twitter. This is a work that is mainly implemented by Aman Yadav, an undergrad student at NIT Sikkim, India, under my supervision, Fatemeh Hindi Janifar, at the University of British Columbia, Okanagan campus. The mobile apps have a very competitive market. They have, like, for example, on Google Play only, there are more than 3 million apps. So because of this, the app developers have a very tough time on understanding which factors are important, and then also analyze different factors that are important to compete with the other apps. The user reviews, the studies on user reviews have been shown to be very useful for the developers because they can identify, for example, the bug reports or feature requests specifically for very popular apps from the user feedback reviews that have been written on Google Play. They can also identify the emerging issues, for example, when a new app version is released, or even the bad updates that are implemented and deployed by the developers. It has also been shown that users post on different social media, such as specifically about Twitter, a lot about the apps. Although there are a lot of works in the literature that study the App Store or Twitter data separately or even in combination to classify the feedback, summarize the issues, or extract information, the semantic analysis of these reviews have been rarely explored. So our goal here is to show a way and also show that the motivation behind this, that the manual integration is still required even for one platform for the app developers. Therefore, we are basically want to show a way that we can show that, okay, semantic similarity is important, and also how to reach that goal. So just consider these two rows in the table. The first row is camera issue and the zoom in problem. If we consider just the words that are used here, these are different issues. However, these are semantically similar issues. On the second row, on the other hand, the login error and camera error, the word error is used as a common. So if you use back of words similarity, then they are 50% similar. However, these are semantically different issues. So the goal here is to find a way to find out how to extract these similar or dissimilar issues and or feature requests from the user feedback. In order to do this, we have collected feedback from 10 apps on 6 categories over 17 weeks to show that these are over different versions of an app. We have collected 87,000 Google reviews and then 50,000 tweets with average feedbacks of almost 2,500 Google Play reviews and then 500 tweets per app version. We have done a lot of data pre-processing, active learning, feature engineering, and classification to ensure about the quality of the data. Then we separated the reviews and tweets for each app, for each version of an app, and then we compare them together pairwise. To do this comparison, we compare the topics, n-grams, bigram, trigram, and 4grams, and also the comments pairwise for each version of each app. So for example, we compare the tweets and Google Plays for version X of WhatsApp. So our approach to find out the semantic similarity between these different reviews is to use the text embedment. We use the word vector, the non-contextual word vector representation for each token, and then we investigate the semantic similarity of the vector representations in 3 different levels: topics, n-grams, and comments that are obtained for each version of each app, and then compare them together. So as I mentioned, for example, for version X of WhatsApp, we compare all the tweets and all the Google Plays in one specific category, which is, for example, all the bug reports category together. Then we use basically 2 similarity metrics. We use the cosine similarity for topics and n-grams, and we also for the n-grams we consider bigram, trigram, and 4grams to find out how similar they are. And then to find out the comment similarity, we use Jensen-Shannon distance on the extracted topics for each comment. And finally, we evaluate the results using manual evaluation, and also we use some statistical tests. So we obtain the similarity scores with our methodology. We also have the similarity scores obtained by manual domain experts, and then we compare the correlation between these two scoring with the Spearman's test, and then our results show that there's a significant correlation between these two scoring. So this kind of methodology for obtaining the semantic similarity is reliable. At the bottom you see that the heat maps that shows the semantic similarity between tweets and Google Play reviews for each version, and you see that only a small proportion of these reviews and basically user feedbacks are similar to each other. We are currently working on the empirical studies for different semantic analysis techniques and also integrating the results with the tool that we have submitted to MobileSoft 2020 reviewees as part of tool track. For more details about the methodology, we refer you to our paper. Thanks for your consideration.